Hello friends, welcome to bisptrainings.com. My name is Sumit and this is my next video in our programming series. In this video, I'm going to talk about the predictive analysis or market basket analysis in R. So, first of all, let's understand what do we mean by market basket analysis. Market basket analysis is one of the most common and useful type of data analysis for marketing and retailing purpose. The It's a modeling technique based upon the theory that if we buy a certain group of item, so you may or maybe more or less likely to buy another group of items. So this is a very common analysis in real day-to-day life. The purpose of market basket analysis is to determine that what product customers purchases together, and it's a widely used technique among the marketers to identify the best possible combination of the product or services which are frequently bought by the customers. So by using this market basket analysis, or with the help of this, the marketers or the shopkeepers, they would be able to identify that which product is popular and where they can place the product in which aisle or in which section, so that the product will mean so that they can increase their sale. So, or this is also called product association analysis, and the outcome of this type of technique in simple terms is a set of rules that can be understood as that if this then that. It takes its name from the idea of customers throwing all their purchases into shopping cart or a market basket during grocery shopping. So I have tried to explain market basket analysis through this picture. From here, it would be, let's try to understand this, that where should detergent be placed in the store to maximize their sale. If a shopkeeper or if the store, they would like to increase the sale of the detergent, so under which section they would like to place this particular detergent or particular item. Similar, we have window cleansing product purchased when detergent and orange juice are bought together. So it's a combination. And how are the demographics of the neighborhood affecting that customers are buying? So how it will affecting? So sometimes what happened when we go to visit, when we visited a shopping mall and we add the items or we put the items in our shopping cart, so sometimes what happened, the others customers who all are doing shopping there, they look the items in our shopping cart and they also look for that particular product. And if any product is easy in it's is in easy reachable to that or to any customer, it would be sold more. So if it is known to retailer that what product people purchase as a group would be very helpful to them or to any other company, a store, or they could use this information to place product frequently sold together into same area, while a catalog or world wide web merchant could use it to determine the layout of their catalog and order from. So this market basket analysis is not only for the retailers, not only for the stores, this would be helpful for online shopkeepers as well, online shops as well. For example, in a footwear store, a shoe is often purchased with a pair of socks. When two or more products are purchased, market basket analysis is done to check whether the purchase of one product increases the likelihood of the purchase of other product or not. So this knowledge is a tool for marketers to bundle the product or strategies a product cross sale to a customer. So let me do one thing. Let me explain you this market basket analysis through an example. And for this, I have created a simple data set named as coffee data set. That's a simple data set I have created, and I named it as a coffee. And there are three transactions has been done. You can see there are three items basically, and total 5 transactions has been performed. So this coffee data set consists of item purchased from a retail store, and for this data set we can write the following association rules can be written. And what are the rules? I will be going to talk about those rules, but before that, you can let's have a look here that uh, we item 1 is purchased, item 2 is purchased, and with combination of item 1 and item 2, item 3 is also purchased. Similar, in out of 5 transactions, in 3 transactions, the coffee powder also have been purchased along with the item 1 and item 2. So basically we'll be going to create rules here, so we can the transaction, or we can call them rules. Transaction can also call them rules. So rules are just for illustration and understanding of the concept, so they might not represent the actual, so this is just for understanding. So let's say we have one rule. Rule 1 is that if milk is purchased, then sugar is also purchased, because usually when we go to buy milk, we think about that how we are going to drink the milk. Okay, so we need sugar for that. And once we bought sugar and milk, we found a coffee powder. We look for coffee powder, because either you want to drink tea or you want to drink coffee. So if you like coffee, so you need coffee powder. So then you will be buying milk, sugar and coffee powder together. So, or it might also possible, it's not only that it's not the item 1 is not only, item 2 is not depend only on item 1. Sometimes item 1 also depend on item 2. For example, if sugar is purchased, then the milk will also purchased. Then it would be a chance that we will be purchasing milk as well. So if, and in this data set, what happened here, that if milk and sugars are purchased, then coffee powder is also purchased. So in this transaction, out of 5 transactions, around 60% in 60% of transaction, coffee powder has also been purchased when the milk and sugar being purchased. So generally, association rules are written in if then format. Like if we buy this, then we also buy that. So we can also use the term antecedent for if and consequent for then. So there are two terms, if and then, and we can say antecedent and consequent. So for the above rules which I told you just now, let me define you rules now. For example, if I remove this and if I look at the rules, so we have, let me define the rules first. Like, if first rule is that if milk is purchased, then sugar is also purchased. We can have rule 2 that if sugar is purchased, then milk is also purchased. And we can have rule 3 that if milk and sugar is purchased, then coffee powder is also purchased in 60% of the transactions in given data set. So I'm talking about with respective to this data set. So with respective to this data set, out of 100, in 60% of transactions, the coffee powder has also been purchased along with milk and sugar. So here, if basically we are working on if and then, that if we buy this product, then I'll buy item B as well. If I purchase item B, maybe I will purchase item A as well. So we can also use the term antecedent for if and consequent for then. So how we are going to calculate this? Basically, how we are going to calculate it, that for the above rules we can understand the following explicitly, that whenever milk is purchased, sugar is also purchased, and this will be go vice versa. If milk is purchased, sugar is also purchased, or if sugar is purchased, milk is also purchased. If milk and sugar is purchased, then coffee powder is also purchased, and this is true in 3 out of 5 transactions. So in other words, we can say that we have support of 3 out of 5 transactions for this rule. So around 60% of possibility. This I have already explained you with the above rules as well, with above 3 rules. So based on the above insights, following marketing decisions can be made. So what decisions I can make by these rules? Like the first rule can be, a marketer can build crossing sale strategies for wooing the remaining 40% of the customer. So if any marketer would like to increase the sale, definitely he will be going to do something. Maybe he can put some offer in combination of milk, sugar and coffee powder, that if you purchase coffee powder, will give you additional 5% discount. Or marketer maybe a marketer maybe he might bundle all these products and give at discounted price, right? And a retail shop manager can stock same amount of sugar and coffee powder in his shop. Like if a retail shop manager knows that the coffee powder not oftenly sold, or only 60% in out of 5, only 60% transactions, in 60% of transaction the customer bought coffee powder, so I will keep a stock according to that. And oh, and this, by using this, he can place these items optimally in a store for the ease of picking by the customers, and much more. So there can be lot of transactions, there can be lot of rules or decisions can be made by looking at the transactions, by looking at the rules. So so we have to understand this thoroughly. Let's try to do it practically, and that how we are going to create a how we are going to perform a market basket analysis in R by using R. So for this video, I'm going to use the default data set, that is a groceries data set, which is available within data set. So for that, I need libraries first of all. So first of all, I'm going to install the packages. So I install package, install dot packages, and the package name is ARULES. So that's the package for visualization. Then ARULES. Then I need to install one more package, install.package, and ARULESVIJ. So that's one more package for visualization. So these two packages I'm going to use. Then I'm going to set the libraries. So I have already installed these packages. So let's have a look whether the package has been installed. So I'll search for that package. The first one is ARULES and ARU. So basically the ARULES is used for mining the association rules, and a rules biz will be used for visualization the association rules and frequent item sets. So these two are used for visualization and data mining. So this package is required. So I add the library as set here. I set the library here. I set the library, 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 and I set this to a rules right now, and add the library. So library has been set, and also I set the library to data set because I want to get the default data sets, and from this default data set I extract the data named as grocery. So these are the data sets, these are the default data sets available within this data set. So I'm going to use groceries here, and I'll load this data set. So if you see, if I load this groceries, we have got around 9,835 dimensions, and uh, basically there are around 169 objects and so on. So if I simply print here groceries, and I run it, see we have around 9,835 transaction rows and 169 items columns. Or we can say that there are around 935 rules set with the data set, and or we can say there are 9,835 bills. So I'll do one thing. I'll use a function here named as inspect, and I inspect this groceries. I inspect groceries here. Groceries. I'm going to inspect this, and here you see these are the items are coming. So basically the list are coming. So these are 9,835 items, and this is one bill. Basically, this we can call it as one bill. We can call it as one bill. And if I want to inspect only first three bills, so I can first three bills. So I can specify. These are the first three bills. In first bill, citrus fruit, semi-furnished bread, margarine, and ready soup. In second bill, we have tropical fruits and yogurt, and third bill, whole milk. So that's how we can load the data set into R. Now, before I actual jump into more deep, let's understand the terminology we will be going to use in market basket analysis. And the terms are, we have mainly two terms. Basically, first one is support and second one is confidence. Support and confidence. So let's understand about support first. So what is support? Basically, it's lingual used in association rules to find out how frequently an item occurs in the data, or in other words, what percentage of transactions does the particular item occurs. So it indicates the number of items a rule occurred over total transaction, that what are the how many times a particular transactions or what has particular item has been occurred in a particular transaction. So for example, in any particular items, let's say whole milk appear in half of the total transactions, then support for whole milk will be 50%. So here I have got whole milk, and let's suppose this whole milk uh, occurs 50%. It occurs half of the transaction. It is in the half of the total transaction. So it means that the 50 it supports is 50%. Then the support for whole milk will be 50%. So, and there is a formula to calculate the support. And what's that formula? That formula will be, I'll just write that formula. So let me write that formula. That formula is support for item A implies item B is equal to, it would be uh, item A intersection or union item B with the total number of transactions. So that's the formula for calculating support. So in this case, in the data set which I have shown you, the support of if milk and sugar then coffee powder is 3:5, because if we look at the data set here, if we look at this data set, in this data set, if milk and sugar, this is one set, this is one rule, and along with this rule we have one other rule, that is coffee powder. So out of 5 transaction, total 5 transaction, in out of 5, 3 of the transactions that supports coffee powder. It means along with milk and sugar, coffee powder has also been picked up by the customer. So the support here is 3 divided by 5, that is around 60%. Let's treat it at a 60%, around 60%. So in the support of coffee powder is 60%. So let's say how we are going to find out the support in R. So first of all, I would like to take a look at the item frequencies. So for this, I use a function here, item frequencies, item frequency, and I would like to get the data from groceries, and if I simply run it, you can see the support with semi-furnished bread is something this, flour is this, salt is this, rice supports this much, oil support this much. So I would like to extract only first item, support provided by the first item. So, and I want means I'm not restricting that how many times it occurs. I just wanted that how it supports in this particular list. So I'll just run it, and you can see here the first item is something frankfurters and it supports 0.059. So this particular item has support or less than a percent here. So now I would like to get the exact number that how many times it occurs in the transactions, how many times this particular items occurs in the total transactions, and the total number of transactions we have is 9835. So we have around 9835 rules or lists. So what I'll do is I simply multiply this figure with total transactions. So I multiply this figure 0.059 multiply by 9835 and we done it. So around 580 transactions. So this particular items has been occurred in 580 transactions out of 9835 transactions. If I look for whole milk, let's look at the whole milk. Let me look at the whole milk. So if we see, that's the first item, and we have finished product, buttermilk, beverages, frozen, white bread, and so on. So these are the items which are available in that list. So see, we have condensed milk and finished products, sauces, citrus fruit, and so whole milk, that is around 0.25552. So I would like to find out that how many times it has been occurred. So multiply by total number of rules. So 9835, and this around 2513. So this particular item has been occurred 2000 and 2513 times in total transactions. So this will give us the actual number. And if I want to get the frequency of first 5 item, similar way, if I want to get the frequency of first 5 item, so I'll just specify to 6. So this will give me the frequency of, this will return me the frequency of first 5 items. So I'll select it and run it. So these are the first 5 items: frankfurter, sausage, liver loaf, ham, meat finished products. Oh, sorry, meat and finished products. And if I want to plot the top 6 items frequency in graph, so these are figures, I want to plot them into graphs. So it's pretty easy. I can simply use another function name as item frequency plot, and I would like to plot this thing. I would like to plot the groceries, and I want to plot top 6 items. Top is equal to 6, top 6 items. So run it, and it has been placed top 6 items. If I zoom it, you can see the highest number of transactions has been done by the whole milk, which is above more than 2.5. Then we have other vegetables, rolls and buns, soda, yogurt, and bottled water, which is around near about 1. So that's the item frequency in relative mode. We can go for absolute as well. We can turn it into absolute. This is relative one. not that this is, it's going up actually, so it's a relative to that. So like this, we would be knowing that which item is popular and which item is sold more in a particular store. Right? Okay. Next, I would like to find out that I would like to look at the item frequencies whose support is high. So for that, I use item frequency and groceries. I want to see all those items whose support is above 10%. So I use support is equal to 0.10 and run it. Yeah, so that's how now you can see here I add here support is equal to 0.10%. So if we look at the graph here, we need to add a plot here. Actually this will not go with the, because it will not go with simple frequency, it will go with plot. So if you see I specify item frequency plot grocery support is equal to 10. So this will show us all those lists whose support is above 10. See, I bound it, it's above 10. If I do not specify this top 6, and top 6 it would be more less than 10. It would be around less than 10, but here we have it is bound to 10, so it will show all those items whose support is above 10. It will be bound to that. And if I do not specify any top 6 or top 10, so it will show all the items. It will display all the items which is below 10 as well. Below 10 as well. So there are lots of items, right? So that's how we can specify. So this is the way how to look at the item frequencies whose support is high. So uh, that's about support. Next we have confidence. Now what is confidence? Confidence is a measure of proportion of transactions with the presence of an item or a set of items which results in another set of items. Or basically this supports for the rule over the support for the incident. So hence we can say that the association rule has a confidence of 60%. 60% here. In support has a rule of 60%. In has a confidence of 60%. So higher the confidence, stronger the rule is. So let me explain confidence thoroughly. Let's suppose we have item A, and item B, and how likely I also buy item C. So the confidence of A and B implies C, that how likely I also buy C. If I buy item A and B, so how it implies to C as well, that how likely I will be going to buy item C. And the formula to calculate the confidence is, it should be something like this: confidence of item, I'm going to place in curly braces, item A and item B implies to item C is equal to support, it should be like support item A, item B, item C divided by support of item A and item B. Now let's understand this confidence with the previous example data set with milk, sugar and coffee. So the number of transactions that include milk and sugar antecedent is, and coffee powder is 3. So together it is 3. The number of transactions that contains only milk and sugar is 5. So the confidence, how to calculate the confidence is milk, sugar and coffee powder divided by milk and sugar, that is 60%. So that's how we can calculate the confidence, that how confident we are that the customer will definitely buy this product. So by looking at the transactions, we can find out the support and the confidence. So now we are ready to mine some rules on our data set, and for this we will be using a priori function. So there is a function available which help us to calculate the support and the confidence. So for that I write m1 and a priori function. So it mines frequent item set association rules or association hyper edges using the a priori algorithm. So I use a priori, and here in this a priori I define groceries. And if when I execute it, a priori, see this, and if you look at this, when I execute this, see m1 a priori groceries, if you look at the data set here, we have confidence 0.8, minimum value is, so that's the default set. So minimum value is 0.1, minimum support will be 0.1, and minimum confidence value is 0.8. This minimum value is the support value, and here there are no rules defined right now. If you look at this, there are no rules. So here I will be using the default minimum support and minimum confidence. So the minimum support is 0.1 and minimum confidence is 0.8. And because see there are no rules, so I'm going to modify this function. And also if I apply here summary, I write here summary of m1. So see there are zero rules. There are no rules defined in m1 because it goes with the minimum value of support and confidence. So I'm going to customize this. I'm going to modify this function, and I'm going to increase the value of confidence and support. So I pass here parameters is equal to list, and confidence, or first we can pass support, and I define support. I give minimum value of support as 0.007, around 70%, and confidence is equal to 0.25, and let's run it. So now you see there are 364 rules. We have got around 364 rules. If I get summary, we have got around 364 rules out of 9,835 transactions, which has got confidence support is 0.007, around 70%, and confidence is 25%. And if I look at this summary, so there are summary, this gives around 364 rules, a set of 364 rules. And also if you look at here, we have the rules length, distribution, left plus right, and sizes. So if you see there are 1 2 3 4 rules, where one rule with one item, two rule which there are one rule with one item, 137 rules with two items, 214 rules with three items, and 12 rules with four items. Let me explain you this more. It means, let's suppose if a customer buy item A, here if a customer buy item A, so then two items means item A, and let's suppose item A and item B, and for this one item A, item B, item C, and for this one item A, item B, item C, and item D. So, and here we will be getting one item 1 as well, and rule size 1 as well, right? So we can also filter it, we can filter it later, but let's understand this first. So here we have item A, item B, item C, and item D. Same with item A, B, C, and these are the items, number of items. So if I'm talking about this rule, so if there are 137 rules where if customer purchase item A, so definitely he will be going to buy item B as well. Same implies on item on this particular rule where 214 rules where customer buy item A, item B. So maybe he will go for item C as well. So he will be going to lift item C. So if I'm going to filter it, and here I want to set the minimum length will be, the minimum rule length will be 2, item length will be 2. So I write here min length is equal to, I set it to 2. So when I run it and summary, you see only rule 2 item, 3 item, and 4 item respectively. And here when I write summary M1, it displays all the transactions and all the items, but I want to show only few rules. So I write here inspect, I want to inspect only item are only first 2 rules. I want to inspect only first 2 rules. I don't want to inspect all the 63 rules, 63 or 64 rules. I want to inspect only first 2 rules. So if I simply write inspect M1, instead of this I write inspect M1, so it will show me all the rules, 363 rules. Where we have, if we look at the, if we get to the first rule, the first rule is here. So here is the first rule where the customer look for herbs. So maybe he will go for, he will buy root vegetables as well. Similar way, if I scroll down for rules where we have 2 items, 2 or more items, so sometimes something like this. So if a customer buy chicken and other vegetables, so maybe he will buy whole milk as well. And you can look at the support and the confidence. Support is around more than 70% and confidence is more than 25%. And here we have support, confidence, and lift. So this lift basically that what's the percentage that a particular item will be lift by a customer. Now when I run this command, it show me all the 363 rules, but I want to inspect only first 2 rules. So I write 1:2, so it will show me only first 2 rules where we have herbs, root vegetables, herbs, and other vegetables. And if you look at this, the minimum support is 70%, which we define over here, and the confidence is 25%. So it is above 25%, and the lift is 4 around lift is around 4. So lift here means that how many times people likes to lift this item with respective to generic purchase. Now if I want to sort rules by confidence or by lift, so if I want to sort it, I haven't defined sorting, but if I want to sort this, so I can write here M1 sort function, and I want to sort M1 and by is equal to lift, and I run it and sorting has been done, and then inspect M1. And when I run inspect M1, again it will show me all the 364 63 rules, and you see it has been sorted. It has been sorted based by lift. So let's inspect first 6 items. So inspect 1:6. So if I run it, you can see it has been sorted based on the lift 4, 3.8, 3.7, 3.5, and 3. It's going down. It's decreasing. Now that we know how to generate rules, limit the output, let's say we want to target items to generate rules. So there are 2 type of targets we might be interested in that are illustrated with an example of whole milk. So what are customers likely to buy before buying whole milk? What are customers likely to buy if they purchase whole milk? and this essentially means that we want to set either the left hand side or the right hand side uh, together. So as you can see here, we have whole milk, other vegetables. So I want to bind it with, on right hand side it will be whole milk, and on left hand side we can have other items. So I want to bind it. So I use that, I copy the above function, and I'm going to customize this function. So I'll paste it, and groceries, we have groceries. So I define here data is equal to groceries, comma, parameters is equal to list, where support is around above 10%. So above is 0.001, 10%, and confidence is above 0.08, 80%, comma, appearance, and I want to display it in the form of a list. Appearance is equal to list default is equal to, so left hand side will be default, and for right hand side I want to bind it with whole milk. So I stick with whole milk. I want to find out that with the whole milk on right hand side, so what other items would be purchased on left hand side. Control is equal to list, and verbose is equal to, so let's run this equation and let's look at the output. It should be LHS, not RHS. LHS, left hand side, and run. So it's done now. I missed T here. So it's done. The calculation has been done. And now I want to sort it based on confidence. So I write M1, or if I simple write inspect, let's inspect first. Inspect M1, and I want to inspect first 4 items basically. So I run it, and these are the first 4 items, where on right hand side we have whole milk, and on left hand side we have other items where the whose support is above 10% and confidence is above 8%, above 80%. And I would like to sort it based on confidence. So I write M1 and sort. So I'll use I copy paste it. I copy paste this sort M1 and by confidence. By is equal to, I run it, and so you can see the confidence. It's working now. So whole milk, and it has, so the equation has been changed, because earlier it was not, because I am displaying only first 5 items. If we inspect all the items, so if I, instead of inspecting 5 items, if I inspect all the items, so there are around, so it will 3,765 transactions out of 9,835 transactions, where on right hand side we have whole milk, and on the left hand side we have other items. Similar way, if I want to find out, I want to keep the whole milk on left hand side, and I want to find out that what are the other items on right hand side, based on, I would like to find out, I would like to find its incident then, and where the confidence is 0.15 and the number of rules will be 0.8. So I'm going to customize it. I just customize it, where on default is equal to LHS. So this time what happened, default is equal to RHS, and LHS is equal to whole milk, and also the support is 0.001 and confidence is 0.15. And also I want the minimum length. I set minimum length is equal to 2, and let's run it. If I inspect the element, You can see now we have on left hand side we have whole milk, and on right hand side we have other fruits with their support and confidence, and the lift we have got. So like this we can inspect the elements, and this will help us to identify, this will help us to take decisions that which item can be placed under which section, so that it would be picked up by the customer. And finally, if I want to add everything in visualization, let's say I want to map out the rules in a graph, so we can do this with another library which we have already imported earlier with a rules viz. So I'm going to use this, and I use plot, and what I'm going to plot is I'm going to plot the above one. I'm going to plot this where I have got the groceries parameter. This one I want to plot this where we have summary around 364 transactions, 364 rules. So I want to add this. So I'm going to add it here. So I write plot and m1 comma method is equal to graph, and I want to make it an interactive graph. Okay, let's do one thing. I'll go with graph right now. I'll make it interactive later on. And if I plot this and run it, you can see the graph has been plotted, but because there are 364 items, so it's difficult to identify the items. It's working, but because you can see there are 364 items, so it's little complicated. It's little messy chart. So what we can do is we can plot only limited items. So I want to visualize only around 10 rules. First 10 rules I want to visualize it. So I run it, and the visualization will be done on first 10 rules. So you can see we have top graph for 10 rules. So where we have flour, detergent, processed cheese, semi-finished breads, whole milk, and baking powder, other vegetables, and root vegetables. And if I want to make it interactive, I write here interactive is equal to true. I set interactive is equal to true and run it. So now this chart become interactive, and you can arrange them. You can arrange them. So see, in most of the transactions, when we purchase any item, along with that the whole milk has been purchased. Now when we purchase baking powder, so we go, or with other vegetables, we did not buy whole milk, we go for herbs, or when we buy herbs, we buy other vegetables. So that's how we can visualize the chart by using a rules viz library, a rules viz package. So that's all in this video of market basket analysis and predictive analysis. I hope you found this video interesting, and this video gives you a clear picture of predictive analysis, or how can we create a market basket analysis, and based on that we can define questions, we can take decisions. If you like this video, don't forget to press the thumb up icon, or you can share your comments as well. You can subscribe our YouTube channel for more videos. If you have any queries, you can write to us on www.bisptrainings.com. Keep watching. Have a nice day. Goodbye.